Well, today's the day. Today is the day that we start making choice in our programs. Our programs start doing just exactly what they're supposed to do, at the exact time that they're supposed to do. They're no longer going to be completely predictable. Now we can add a little bit of chaos into the equation. And the way we're going to do that is by modifying the flow of our program. Now, up till now, we've always been under the impression that our programs simply run from top to bottom. So what I mean by that is, let me see if I can get my pencil going here. Like typically speaking, our programs simply run straight down from top to bottom, and there's no deviation whatsoever. What we're going to be doing over the next few lessons is creating a system like this, where yeah, we can still run top to bottom, but maybe we can divert, do something else, and then come back to the path. Skip over this chunk and just continue on. Or we might run into a situation like this, where there is no standard path. So in this case, we call this one choice. Here we have two choices. Eventually, we're going to get into a situation where we have infinite choices, where we come down and it could be boom, 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 boom. And they're all eventually going to lead back to the standard path. Eventually, everything comes back. So the way I want you to think about it is think of it like a train. And that train has come trucking down those tracks, boom, 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 boom. But sometimes it comes to a switch in the tracks, and it can choose to go left or right, depending on what's going on. Now, if it chooses one of these paths, it can't back up. There's no backing up for these trains. They must keep going forwards. They're going to keep going on this path and then continuing on. And same over here, we have the option, but there's only a left or right choice. They have to make one of the choices. And then down here, we have an infinite number of choices. Really, we mean three or more. Three or more choices. Okay? That's the general goal of what we're going to be doing over the next few lessons. And this is going to add a completely new dimension to the way your programs are going to work. Get back to where I was. There we go. So, how do we do this? Well, we do this through the use of something called a control structure. A control structure is just a simple programming element that allows us to change the flow of the program. Now, we use the term flow because some people, instead of using the train analogy, will use a river analogy. And the river just continually flows down that path. Now, I typically don't use the river analogy because when a river comes to a fork in the road, it divides and can go and goes both directions. In our code, it doesn't. In our actual code, it has to choose one of them. That's why I prefer the train analogy, because the train has to make a choice. So no longer will our programs have to simply flow from top to bottom. We are going to be able to manipulate this. And we're going to do this using one of the most powerful control structures that we're going to learn in all of programming, which is called the selection statement. Now, selection statements come in a lot of varieties and a lot of flavors in the world of programming. So selection statements are programming instructions which the flow of the program will use to select a different path based on if certain conditions are met or not. So it might be something as simple as if the user's age is greater than 16, then do the driving path. If it's not greater than 16, then go the walking path. It could be something as simple as that. Or it could be something completely more complex. It might be things that are based on angles and all sorts of math and crazy different things. It depends on what we want to do. And they don't even have to be based on one piece of data. It could be based on many pieces of data, not just one individual one. So, as I said, there are 4 different varieties of selection statements that come in most programming languages. Now, there are some variations depending on the language you're on, but for the most part, most languages support these 4. The first one is called an if statement. This is when we have one option or the standard path. So that was that first one that I drew that was a straight line and it had one deviation to the side. So that is our if statement. Choose to go another path or do not. The second one is our if-else statements. That was a second diagram which actually had an actual fork in the road and it went left or it went right. There was no standard path. It had to make one of the choices. So these two things together are what we call simple selection because there's no more than 2 choices ever that we're going to be dealing with. But then we get into the next few, which are called multi-selection. Multi-selection is when you have up to infinite choices, but you got to have at least 3. So the first one is called an if-else-if statement. So we have infinite options, and there's at least 3 of these options, and there's no standard path. And then finally, something called a switch statement. It's pretty much like an if-else-if statement with a slight few modifications on that. So these two, number 3 and 4, they're what's called multi-selection because we're choosing from many, many, many choices, multiple choices. Whereas the simple selection is just one or the other, at most. Simple selection versus multi-selection. Great. Oops. Moving on. So in order to be able to make choices, that means we have to be able to compare values. Now, sometimes we're going to be comparing numbers. Other times we're going to be comparing text. Sometimes we might compare Boolean data. It all depends on what we're working with at that point. But there definitely is going to be a comparison made. And that comparison is going to yield a true or false. So is age less than 18? Or is age less than 18? Then you can't vote. Otherwise, you can vote. Okay, so that's a comparison. That's a true-false statement. Is age less than 18? True or false? There's no gray area there. So that's all of our comparisons. They're all going to yield a true or false. So how do we do this? In order to be able to actually compare data, we need some new operators. We've already learned mathematical operators or arithmetic operators, which basically add, subtract, multiply, divide, modulus. You all remember those. But now we're going to learn some comparison operators. Some of them you already know. You've seen them in math class. Others, they're variations on that. So, in order to demonstrate this, I want you to keep the following things in mind. Assume we have a variable called x, and it has the value 5. And we have another variable called name, and it has the value Bob. So for all these comparisons down here, we're going to use that information as our cornerstone. So the first operator is equals equals. What this does is it compares two values. Is the left exactly equal to the right? Now, you might be thinking, why don't we just use an equal sign? Well, we can't, because we already use an equal sign for something else. We use an equal sign to assign a new value. You can't use it for both. Can't have your cake and eat it too. So in this case, equals equals means compare. Equals means assign. So we're saying, does the current value of x exactly equal the value 5? Well, x is 5, so yes, it is. So this returns a true. Great. Now, when we want to compare strings, we can't use the equals equals operator. Well, technically we can, but it doesn't yield the result that you want all the time. When we get into more complex things, you're going to find that it fails. So in order to always be safe, use this command, dot equals. When you use dot equals, it will compare the first variable, the variable against a value. It could be another variable, or it could be a straight value. So here we say, is name exactly equal to Fred? And well, no, name is Bob, so it fails. I could have just as easily put another variable in there as well. I could have said, is name exactly equal to name2? Right? Whatever variable, whatever value name2 holds. So then we get into the next operator. If we can't check equals, let's check not equals. So not equals means do they not match, true or false? So here we're saying, is the value currently is stored in 5 not equal to value 8? Well, let me rephrase that. Is the value currently stored in x not equal to the value 8? Well, no, because 5 does not equal 8. So this is a true statement. Okay? 5 does not equal 8. True. All right, now these next two you've seen before in math class. Greater than, less than. Now, it's always a comparison from left to right. So is x greater than 8? Well, the current value of x is 5. So is 5 greater than 8? No, it fails. Now we have less than. Now less than. Is 5 less than 8? Yes, it is. True. Great. Now let's make it a little bit more complex. So here we have the greater than and equals to sign. Now in math class, you usually see it something like this. Right? Well, we can't, that symbol doesn't exist in any programming language at all. So we actually have to use both of these signs, greater than or equal to. Now listen to the way I say that. Greater than or equal to. That means either way, we're still good. So in this case, we say, is X greater than or equal to? So it checks each one of those options one at a time. Is 5 greater than 8? No. Is 5 equal to 8? No. So they both failed. So that's a false. So now we have less than or equal to. Is 5 less than 5? No. Is 5 equal to 5? Yes, it is. Ding, 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 ding. We have a winner. So true. This actually results in a true because it's less than or equal to. Either one. Either one. So this is how we're going to be comparing our data. And every time we do a comparison, we're going to result in a true or a false. And this is going to allow us to make choices in our paths. Now remember that term comparison, because that is the key to everything today. So this is the general syntax of an if statement. If some condition is true, execute the following code. You'll notice that it has its own set of brackets. Now we always learn that if you have an opening and closing set of brackets, whatever's inside belongs to that piece above it. So the code inside, the block of code that is executed if condition is true. So this code only gets executed if whatever this condition is actually true. So let's do an example so you can see this in action, because obviously it can get pretty complicated if you don't. So imagine we have two variables. Int hour has the value 23. String greeting has the value hi. Now I want to say if hour is less than 18. So do that in your head right now. Is hour less than 18? If it is less than 18, then I want to change the value of greeting to good day. Now, obviously, looking at this, you can probably think, well, what are they talking about? Oh, they're talking about a 24-hour clock. I get it. 18 is 6 p.m. So what I'm saying is, if it's less than 6 p.m., set greeting to good day. And then finally, we're going to display what the current value of greeting is on the screen. So take a second and pause the video and try and figure out what will actually be displayed on the screen from this. Okay, assuming you're back right now, we look at this. We say, well, is hour less than 18? Well, no, it's 23. So it fails this. So let me draw a little line so you can see how this actually executes. Where's my pencil? So what actually happens here is the code will flow from top to bottom. It'll do this line. It'll create a variable, store the value 23, create a variable, store the value high, then it'll work down and it will do this comparison. It'll say, is hour less than 18? No. So it's going to jump over and skip this code and continue on with the rest of the program because it failed the check. So greeting still has the value high. So what should we see on the screen right now? We should see high. Great. Okay. So that's your simple if statement. One choice. It either goes in the code or it does not. So it stays on the standard path or it deviates and does some extra stuff. Okay. Moving on. What if we have two choices? So you notice that the code above looks pretty much identical. We still have if condition, do the code inside if that condition is true. Else. So this is an if-else statement. And what else really means is everything else. It's literally everything, including the kitchen sink that wasn't already tested. So we're going to test for something up here. And if that one fails, we're going inside of here no matter what. So this is that fork in the road. You're either going left if it's true, otherwise you're going right, no matter what. There's no choice in the matter. It's got to be one or the other. So let's read the comment here. Block of code that is executed if condition is true. Down here, it's block of code that is executed if condition is false. Let's take a look at this code. So again, we're coming into the same scenario. I still have my hour, which is 23, my greeting, which is high. I still have my same check. Is hour less than 18? If it's less than 6 p.m., we're going to set it to good day. Great. But if it's not less than 6 p.m., if it's not less than 18, I'm going to set it to good evening. Because that means it's at least 6 p.m. at that point, right? It's 6 p.m. or more. So in that case, we're going to set greeting to good evening, because 6 p.m. on, good evening is a fair estimate. And then finally, we're going to display the results. Pause the video, try and figure out what's going to be displayed on the screen again. Okay, I'm assuming you're back again. So let's take a look at what I did. Let me just adjust my microphone a little bit here. Okay, so again, the program comes in. It defines a variable called hour, sets it to 23, defines a variable called greeting, sets it to high, And down here, it says, is hour less than 18? No, it fails because hour is 23. 23 is not less than 18, so it skips over this. It will automatically go in here. It will execute this line of code and set greeting to good day. And then it finishes and continues on. Now we can have as much or as little code inside of these brackets as we want. We can even have more if statements. You can have whatever you want as long as it's valid code. Doesn't matter as long as it's valid. So you see the flow of the program. It skipped over this option. But what if I change this? Let's change my colors for a second. Let's see. Can I change my colors? I don't know how to change my colors. Okay, let's just assume. Let's assume that I scratch this out for a second and I make this 15. What's going to happen now? Well, now when it comes and tests this, we'll do it over here. It's going to say, is 15 less than 18? Yeah, certainly is. It's going to come in. It's going to execute this line of code. There's no more code in here. So it will jump out and it will skip the else statement and come down to the output line. It doesn't need to check the else because it already went in the if statement. It will only ever go into one of them. Remember how the train flows down the tracks. It can't backtrack and it can only make one choice. So it has to choose one of them. I don't know if I can undo on here or not. I don't know. We'll keep going. I'll come back to that after. All right. So we're going to get good evening as a result because it actually, if you keep the original data at 23, because 23 is not less than 18. So a few notes to keep in mind here. Number one, the else acts is kind of like a catch-all. It's like a safety net, which means whatever has been tested above, this condition is everything else that's not yet tested. What I do want you to notice is that there's no brackets here. We're not actually comparing anything. We don't need to because it means everything else. There's no point in it. And the final point was one I already made. Only one branch of code will be executed. If the flow goes into the if statement, the else code is skipped. If it doesn't go into the if statement, the else code is forced. That's it. So that's the idea of simple selection. So if you want, take a few minutes and try this practice code out. Create a simple program that asks the user for their age, and based on whatever age they put in, you're going to compare that against 18. And you're going to decide whether you should display the word child or the word adult on the screen. I'll let you be the judge of which one comes when. Okay, that's it for simple selection. Coming up soon, multi-selection.